Hi again, my name is Josh Wentz, and we'll be talking about the biggest IoT opportunity in buildings, and it's a lot closer than you think. So I work for a software company called Lucid, and we're in Oakland, California. So we're a small building software company, and I'm a software product architect there. My background is in architectural engineering and information sciences, so I've always wanted to work at this intersection of buildings and computers before it really even existed in school. And Lucid kind of created something really exciting to marry those two passions called Building OS, which is this cloud-based building management platform. And before diving into that product, I kind of wanted to rewind to look at the building before IoT, before the Internet of Things, before the Internet at all, and to root that in the life of a building. And the life of the building as we know it today starts with an owner conceiving of the idea of a building. And then from there, it often gets passed to an architect who's designing the building and taking a lot of time to design it. We've seen so many presentations today where all of this data is being pulled from all kinds of different sources to design a building. And then it often gets passed to an engineer who's modeling the mechanical systems, the electrical systems, the lighting systems, and then eventually passed off to a contractor, and the building is built. And that's about 3 years of the building's life, the AEC. And then the next 80, 100 years, however long a building stands, the occupants are left to use the building and live in the building that the people beforehand created for them. And it's a very one-way process right now when it comes to that life of the building. And that's a serious problem when it comes to the building infrastructure that we have. The built infrastructure of buildings, we've seen the stats so many times before, 2/3 of all US electricity is consumed by buildings. And a lot of that is because that very linear path that I was showing along the life of the building is linear. It's not a feedback loop. The first company that I worked for, ASGG Architects in Chicago, I worked for a mechanical engineer, and I remember asking him for the past 25 years how you've been submitting the mechanical design for a building. And for those 25 years, do you have any idea how those buildings are performing? And he said, no, not one. Well, everybody's out there, a lot of architects here, only a few mechanical engineers. How many in the room, just for a show of hands, are actually tracking the building throughout its life, the 80+ years? Just a show of hands, how many people are actually in the loop as to how that performance or that energy model is actually performing throughout its life? 2. That's why we're here. So we hope to really make that connection between the architects and the engineers much easier than it is today. I hope in a few years from now, many more than 2 hands will be raised. So I want to show you, I really want to look back into history as to why that is. Why is it so tough to track a building? And a lot of that is rooted way back in the 1800s. For all of time, buildings have been very dumb. We design them, and then they're built to spec. Based off of building codes, decades before the actual building is built. So then it continues throughout its life with very few people actually knowing how that building should operate. It wasn't until the very end of the 1800s where we finally gained this pulse of the building. And I want to touch on 6 different points throughout the 1900s that really started to shape how we could track that building throughout its life. And it started in 1886, whenever we started to get this pulse. We have some lifeline to the building. We know it's alive, and we knew that by Warren Johnson creating the thermostat, where there's an actual temperature of the building. You can take, in the same way that you can take the temperature of a human being, you can take the temperature of a room, and the room can tell you how hot or cold it is. That was the first time that we started, the building started to speak in a small way back to the occupants. It wasn't until a lot later in the 1900s, the 1980s, where the building finally got this voice. And that voice was manifested in all kinds of different terms. I'm sure you've heard of many of them. Starting in the 1980s, moving into the 1990s, building management systems, building automation systems, BMS, BAS, direct digital controls. There's a long list of all of these different names. But all of them manifested themselves in these different, very siloed control systems of the building. Things like Johnson Controls, Honeywell, Delta, Automated Logic, and Siemens. These were the languages that a building spoke. And I don't even want to call them a language yet. We'll call them something a little bit less than that. But at this point in history, only 6% of buildings had an automation system. And I'd say that was even less earlier in the 1980s. So you have 5 million commercial buildings that aren't being tracked. There's no way, there's no medium to even speak to the architects and the engineers, all of you in this room. And that's a big problem. Throughout the 1990s, all of a sudden, moving from the pulse to an actual voice, we started to get this dialect of the building. And that dialect came in many different forms. And a lot of designers in the room, not the best designs up here for post-construction. This is what the occupants or the facility managers had to use throughout the life of the building. And to understand any of that is really tough. You need a PhD just to understand how to use one of those. But the buildings that I was showing, they were using all of these. So this 6% of buildings almost became this aristocratic class, this class of buildings that could actually speak some dialect back to the occupants. And it wasn't until the 1900s, the 1990s, whenever the internet started to develop, that there was this backbone, a way to take all of these dialects and standardize them in the cloud through the backbone of the web. So Lucid has started to, Lucid's been around for a decade now, and it's a startup, like Jonathan said, I joined about a year ago. They started taking all of these dialects and bringing them up to the web. So the tough part that we did is we figured out the puzzle of each building hardware and software system and figured out how we can take that puzzle and push it up to the web so we can normalize it and make sense of all of it for everybody inside of the building. But still, there are 94% of buildings, the entire building stock that we have, that has no automation system, which is why very few hands were raised. In 2000, we started to hit on the face of a building and how the building started to speak beyond just a dialect, but through some visual. And that started a decade ago when Lucid started, which was a campus project in Oberlin, Ohio. And the very first project we had helped university dorms compete on who's spending the most energy. And how we engaged the students was through a dashboard inside of the building. So at this point, one building could speak to many different occupants that would come and see the building. And at the same time, all the occupants, everybody here, all of us, we spend 90% of our time indoors. And we all have this need through the societal green initiatives throughout the entire nation to spend less energy. But we don't really know how to do that. We don't really know how the building is actually performing. So this is the competition that we first run that kind of triggered the start of the startup, which was this competition amongst dorms. And competition and peer pressure means everything to college students. So we reduced the left one by 55% and the right one by 56%. So it like more than 50% decrease across these buildings through this competition life cycle. And this is something Lucid has done since then. We have something called Campus Conservation Nationals. We have something else called Connected Cities as a way of allowing new competitions to happen on a larger scale today. And in 2013, IoT exploded, the Internet of Things. All of these devices beyond just the aristocratic few buildings in the past, which were just Johnson Controls, Honeywell, and Siemens, now have been brought down to a much lower barrier to entry. So you can buy devices like a Hue light bulb or an N-metric power strip to track your office or your desk, and it goes right up to the web. So newer companies, newer hardware devices are skipping this entire idea of a BMS, a BAS, BACnet. None of that means anything to new hardware developers. They're sending things right up to IP. So the internet backbone that we slowly started building all of these integrations upon are now expanding beyond just archaic systems to very relevant and new technologies. So this is when 2013 came around, and we realized the language of the building. We moved beyond the pulse, the voice, the dialect, and the face, and now we're starting to standardize a language to that building. And through this time, over the decade that Lucid has been around, we've created over 170 vendor device integrations. So we talk about data. There's so much data behind each of these hardware and software systems, from smart meters to solar panel systems, to circuit board systems, to control systems, everything that it took. So this grew organically, and this couldn't have happened very quickly, which is why it's taken us a decade to really build this platform that we're calling Building OS. And each of them takes, on average, this past year I was working with integrations, and we finished about 3 to 5 within the year. And a lot of that is just because of the dependencies, the external dependencies of, we integrated with Smart Meter Texas, and I have to work with IBM to set up Smart Meter Texas, and they have protocols that aren't the latest of technologies, but we have to integrate it in order to pull in 15-minute interval data for the state of Texas. So we did that, but it took 9 months' time. So that's why it took us so long to really get to this, and we're really excited to say that this is the value over the time. It wasn't the dashboard. It's all of the integrations that we have to buildings. And with that, Building OS was conceived, this idea of an operating system for a building. And we focus entirely on the software layer that integrates all building subsystems. So we focus entirely on buildings, whether it be a hardware or a software system. And we bring that up to one single web interface. So you don't need to understand how that one device brings its data up to the web. You can just start to make sense of all of the buildings that you have across the portfolio. Traditionally, rewinding back to this feedback loop, how would you ever track how a building's doing throughout its life? One way is to track the utility bill data. So every month, that building that was designed and engineered, it has a dollar and a consumption and a demand as to how it was actually performing throughout its life. But those are 12 data points throughout a year. So it's really tough to change anything throughout those 12 data point times. If you take those 12 pixels that we have and we expand them to 3,500 pixels, which is the equivalent of 15-minute interval data, which is what we pull from smart meters, you see a very full picture as to how the building's performing. It's much more engaging to see something on the right. It's something that makes sense. How can you understand what to change in your building on the left? So our application that kind of takes this idea and puts it into practice is called a heat map. And I'm sure you've seen these before, but why it's exciting here is this is a real building. Fortune 500 building that brought all of their data online and realized how terrible their scheduling was of the building. And they went through the process of understanding when the startup and shutdown times were and brought down the consumption 137,000 kilowatt hours. So that's great. That's great for the environment. But how much is 137,000 kilowatt hours? I studied architectural engineering and did many energy modeling classes, and I still have very little sense as to what 137,000 kilowatt hours is. Is that good? It looks like it. So what we took last year is this language that we're talking about is not just one that just the most technical of people can understand. We've spent a lot of time taking these technical engineering terms and making them approachable, and making them approachable to anyone. A 5-year-old has an idea what a $20 bill is underneath of her pillow for getting money from the tooth fairy. So everybody has some sense as to what a dollar is. So we took not bill data, but interval data, and we created a utility rate engine that converts consumption of any type to dollars. And the aftermath of that is you can see this same very clear picture in a way that's actually evokes some emotional response. $15,000 we all have a sense of. What portion of the amount of money that is to you? So no matter how far along you are, you can understand how much $15,000 is. So this takes us to 2015, where just earlier this year we launched BuildingOS 2.0. And we took that very standardized language and we turned it into a personality. And what we mean by that is each building has a way to communicate with many different people. So at this point, when a building has a personality, we have many buildings that are communicating with many different people. And what this is BuildingOS 2.0 that is really the face of the building. It tells you who the building is and how the building's performing. You can drill into individual cards that break down the dollars and the actual consumption. This is then a higher level view, which is the organizational level. So this is an organizational building landing page that shows you all of your buildings. So this is how all buildings are now communicating to the owners and the occupants as to how they're doing across the entire portfolio. So that was just a very brief history as to how we got to where we are and how it's now possible to take this very linear process within the AEC world and leaving out this O of operations and making it circular. So this wall that has traditionally been put up, so architects and engineers have no idea what's happening within the building. It can now be a loop. It can be a feedback loop that as soon as that building is connected with BuildingOS, any engineer, the original engineer or designer of the building can log on to understand how it's doing. It can check in on the actual health of the building as a doctor does for a human being. So BuildingOS is really here to connect buildings, all buildings, and all people in a very simple way. And data has been a part of our DNA from the very beginning. Our original name was actually Lucid Design Group, so our VP of Design likes to say that's our middle name. We have an API that's coming soon in 2016 that we're really excited to collaborate with architects and engineers on, so please find me after if you'd be interested in obtaining 15-minute interval data, 35,000 readings for your building throughout its life. Lucid has 10,000 buildings online now, over 170 different integrations, and a billion square feet of under management. And you can check us out at lucidconnects.com. If you're going to be around New York, we actually have an event. We're traveling throughout the nation through a Connected Buildings tour. So there are 7 different locations, and for New York City, that's going to be this Wednesday. We'll be presenting around the idea of what BuildingOS is, and you can check in and really get to know Lucid a little bit more. Again, my name's Josh again, and I'll be around for the hackathon. Feel free to catch me if you have any other questions about BuildingOS. We're excited to connect the actual building throughout its life to the original designers and engineers. You guys are the ones that should have access to it. Thanks.